Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study about analog to digital and digital to analog converters and their specifications. We will start with what is an A to D converter and D to A converter, and then we will study the specifications individually of analog to digital and digital to analog converters. So let us start with our topic. So let us first see that what is analog to digital and digital to analog converter. In this physical world or real world, most of the signals are analog signals. Analog signals are those signals which changes continuously with the time. Means at every instant of time we will be having different values for the analog signal. So if we represent an analog signal, it will be like, if this is the time on the x-axis, and on the y-axis we are having the amplitude of these signals. So at every instant of time we will be having different values for this signal. So if we join all these points, you will get these analog signal. So we can see that at every point there is a different value of this signal. Okay. So this is an example of an analog signal. So most of the signals which are present in the physical world, they are the analog signals. But nowadays the instruments and equipments which are used and the various instruments which we are having, they are all using, and technologies, they are based on the digital signals. So if we see a digital signal has only two values. Either it will be 0 or it will have 1 value. Okay, so only two values are there. Again here, if we see the amplitude, this is time. So this is a digital signal. It's not necessary that digital signal is having only 0 and 1 value. It is in the case of binary numbers. Okay, it means that 0 is indicating the low level and 1 is indicating the high level. Okay, so 0 is this position, 1 is this position. Again 0, again some value. Again 0, again some value. It's not necessary that it is 1 always. It can be any number. Okay, any binary number can be there. Okay, now if we are taking only the two binary digits, 0 and 1 can be there. It can be 0 or 5, 0, 7, 5, 7. So there the output is in the form of binary numbers only. Okay, so this is an example of a digital signal. So as I have said that all the signals in the physical world, they are the analog signals, and the technologies which are nowadays working and the equipments and instruments, they are dealing with the digital signals. So all the systems are based on the digital signals. So there occurs a need of converting these analog signals into the digital signals. Okay. Also there are some systems which deal with the analog signals. Okay, so if we are having digital signals, then that digital signal is to be converted into the analog signal. So both side conversion is necessary, analog to digital and digital to analog. So for that purpose, converters are used. Converters are those instruments which convert either an analog signal into a digital signal or a digital signal into an analog signal. So let us first start with the digital to analog conversion, that how a digital signal is converted into an analog signal. So what is the function of these D2A converters? They convert the digital number into an analog voltage or current. In measurement system, mostly the voltages and currents, these are the most important signals. So we want that every signal should be converted into either voltage or current. So the digital number, it is converted into an analog voltage or current. Okay, now where these converters are used, these converters are mostly used where the analog signals is to be handled by the instrument. So like in the variable speed motors, also in the electroacoustic transducers, an example of electroacoustic transducer is the speaker. So all the applications where we require an analog output, so there the D2A converters can be used. Another example of this is in the CD players. Okay, in CD players also the digital signal is to be converted into an analog signal. Okay, so how the converter, D2A converter, converts the signal? So D2A converter, it is a circuit or it's a chip. It is in the form of a chip that adds up a number of voltages under the control of a digital signal. This will be clear to you from this example. So this is a 3-bit D2A converter. We are getting three bits as our input. Okay, and these 3 bits are either 4 volts, 2 volts or 1 volt. So these are the switches here. According to the switch which is closed, according to that the analog signal will be generated. Here we will get an analog output. So if suppose that 4 volts and 2 volts, these two switches are closed, so 4 and 2 will be added and we will get an analog output which is the 4 plus 2, that is 6 volts of an analog output. These two are summed up and together we will get a 6 volts of output. Suppose that 4 and 1 are they are added, then 5 volts of output we are getting. So what the D2A converter does, it adds up a number of voltages under the control of a digital signal. So according to the digital input, we are getting the analog output. Just like this, if we use the zeros and ones arrangement, then zeros and ones, suppose we are having 0, 0, 0, 0. So the output generated will be 0 volts. If we are having 0, 0, 0, 1, then 1 volt of output will be generated. So it is the case of a 4-bit D2A converter. We are getting the binary input and we are getting an analog output. We will get a signal which is of the amplitude 1 volt. According to that, suppose if we are having 1, 1, 1, 1, then we will be getting 15 volts of output signal. Okay. So in this way, the input to the D2A converter is a digital input. A digital number will be there. Okay. And that number will be converted into an analog signal. So this is the main working of the D2A converters. So here we are studying about the specifications. Because we know that D2A converters, they can be used in different applications. So depending upon the type of application, the specifications specifications are given for every converter. So according to our need, that for what application we are using the converter, according to that we will choose the converters seeing their specifications. So specifications are most important thing for the selection of the converter for different applications. First specification is accuracy. Accuracy is defined as the maximum difference between the output and the input. That how accurate our measurement is, how close our measurement is to the true value. Okay, so accuracy is the maximum difference between the actual output and the theoretical output. Means what the measurement which we are doing, what the conversion, like the digital signal is converted in analog signal, how accurate that analog signal is to the digital signal, means to the actual value, how close the actual measurement is to the theoretical value. Next specification is resolution. Resolution is also known as the output step size. And it is given by the So it is the output voltage range divided by the number of possible output levels. Means the smallest amount of output that can be correctly measured by the instrument, by the converter. So the output voltage range, that what is the range of the output divided by the number of possible output levels. Next specification is settling time. Okay, settling time is defined as the time taken by the output to reach a percentage of the final value. Suppose that our final value is 100%. Okay, 100 is our final value. Until now we have reached to 60 value. So how much percentage of value we have reached up till now? That is the settling time. Time it takes the output to reach a percentage of final value. Suppose that how much time the system is taking to reach the 70% value of the final value. Okay, 70% is at reach, so the time which is taken, that is the settling time. How much time it takes to settle to this much value? Next specification is the linearity. It is the linearity is defined as the maximum difference between output and a linear interpolation between minimum and maximum values. That means the output is how much linearly related with the input. What is the relationship between them? So maximum difference between output and a linear interpolation between minimum and maximum values. So suppose that this is our graph, this is our output, this is the maximum and the minimum values at this time. Okay. So the difference between the output and the maximum and minimum values is that linearity. Okay. Next is monotonicity. So a converter is said to be monotonic if there is an increase in digital output causes an same increase in the analog output. So if we are increasing the digital input, then in the output also we are getting the same increase. Okay, then we will say that the converter is monotonic. Okay. So these are some of the basic specifications of the D2A converter. Accuracy, we see that how accurate the converter is, resolution, its settling time, its linearity and its monotonicity. Okay. So this was about the D2A converters. Now comes the A2D converters, that is analog to digital converter. Let's see that how they convert the analog signal into digital signal. So these converters convert analog signal into digital signal. The best example of the analog to digital converter is the comparators. What the comparators do? This is our reference, this is our input signal and this is our reference signal, and then we are getting the logic output. Suppose that our reference input is here, we have applied it, so we have kept it as 5 volts, and here we have applied the input voltage. Now our input voltage is continuously changing. Suppose that its value is 2.5 volts. The comparator is going to compare that whether the reference, the input is equal to the reference. If it is not equal, then it is going to give us the output as 0. If it is equal, then it will give the output as 1. So when V input is equal to V reference, then output is logic 1. If V input is not equal to V reference, then it gives the output 0. So here you can see that the input is a voltage, that is an analog signal, and that analog signal is converted into an digital signal, a binary output or a logic output we are getting. So comparator is the simplest example of the A to D converter, which convert the analog signals into the digital signals. Now let's study the specifications of the A to D converters. So just like the D to A converters, here also the specifications are very important, like resolution and accuracy. Conversion speed is also taken, that how fast the conversion is done. So that is also a very important specifications for the A to D converters. Other specifications like linearity and monotonicity are also similar to the D to A converters. If we talk about the resolution range of the A to D converters, then they can give resolution from about 6 to 18. 6 means that it is very, in the case of very fast A to D converters, they will give the resolution of 6, and 18 resolution will be given by the very slow A to D converters. So specifications for the A to D converters are the same, their definition remains the same, just their values will be changed. So whenever we want to choose the converters for some application, first we see that specifications, that how much accuracy we require, how much linearity or resolution is required in that application. According to that, we are going to choose the A to D or the D to A converters. So in this video we studied about the specifications of the digital to analog and analog to digital converters. These converters convert because there are different requirements. In some systems we require digital signals, in some systems we require analog signals. So according to that need, the D to A or A to D converters are used. Here we studied their specifications, that what is the definition of these specifications and how they are defined for the converter. So I hope that this topic is now clear to you. Thank you.